Our goal in this experiment is to calculate the molarity of acetic acid in vinegar. So this is the data that you should have collected in the lab. You'll have two trials. I'm just going to do one as an example. So you should have the volume of the vinegar sample that you started with, the initial burette reading before you started your titration, the final burette reading at the end point when it turned pink, and then the molarity of the NaOH, and that is just going to be told to you in the lab. So this is the reaction that's going on here. This is acetic acid, which is the acidic ingredient in your vinegar that we are trying to calculate the concentration of. So since we know the molarity of NaOH, if we can figure out the volume of NaOH that we need to exactly neutralize all of our acid, we'll be able to calculate the concentration of this acid as well using the data that we collected. So the first thing we need to do is calculate the volume of NaOH that we used. So all this is the difference between our final and initial burette readings. This is how much, this is where our liquid level was when we started. This was where it was when we ended. So the amount that we let flow into our flask is the difference between these two values. So this is just our final burette reading minus our initial burette reading. So for us, with this example, I'm going to do 10.92 milliliters minus 1.56 milliliters, which gets me 9.36 milliliters. So we're going to need that volume later on when we go to, in the next step actually, to calculate the moles of NaOH used. So the way that titrations work is really just utilizing stoichiometry. If I know how many moles of NaOH I used, the balanced reaction lets me calculate how many moles of acid there must have been. We're adding just enough base, just enough sodium hydroxide to react with our acid, so we can use stoichiometry if I know moles of one to find moles of the other. So my moles of NaOH is just going to be the molarity of NaOH, which is the same thing as moles per liter, times the volume of NaOH in liters. So in step one here, we calculated the volume of NaOH in milliliters, so we just need to convert that by dividing by 1,000. The molarity is given to you in the lab. So we have a molarity in this example of 1.03 moles per liter. Our volume in liters is 0.00936. So this value is coming down here. Our molarity is given, and this gets us 0.0096408 moles of NaOH. So I'm carrying some extra sig figs at this point. I don't want to round until the very end to avoid any unnecessary error. So our next step is to calculate how many moles of acetic acid there must have been in my vinegar sample. So this is just a simple stoichiometric conversion. This is going to be equal to the number of moles of NaOH that we just found, multiplying by the coefficient ratio to convert from moles of NaOH into moles of acetic acid. So for this reaction, well, we want moles of NaOH to cancel, so that's going to go on the bottom. We want moles of acetic acid to be the new unit that we're converting into, so that is going to go on the top. So our coefficients here are both 1. So this is just going to be 1 over 1, which means your moles of sodium hydroxide and your moles of acetic acid are actually going to be exactly the same. So if we take our moles of NaOH that we just calculated, it is 1-to-1 stoichiometry. So we get the same value for moles of the acid. So in this one, we're taking the value we found back here and plugging it in along with the coefficients from our balanced reaction. We will be doing other titrations in the future, so I'm hoping this will serve as an example for titrations to come as well. Hence, I'm trying to be really clear about what numbers are coming from where. And then our last step is to just calculate the molarity of the vinegar, which is going to be the moles of acetic acid that we just calculated, divided by the volume of your vinegar sample in liters. So this is going to be coming from back here. So we have the volume of vinegar in milliliters. We need to make sure we're doing moles divided by liters. So our molarity is going to be, running out of colors, our moles of acetic acid divided by the volume of vinegar in liters. So 8.42 milliliters is 0.00842 liters. So this was our moles. That was our volume of vinegar in liters. And this gets us a final molarity of about 1.144 molar. And the last thing we want to do is round to an appropriate number of significant digits. This is an experiment where we are taking measurements and doing calculations based on those measurements, so we should be rounding our final answer to an appropriate number of significant digits. So if we look at the data that we collected, we see that we have 3 significant digits, 3 significant digits, 4 significant digits, and 3 significant digits. So 3 is the lowest number of sig figs that we have. So we should round our final answer to 3 sig figs to match that. So 1.14 is the molarity that we would want to report for this set of data.